peace has rarely been the status quo for Earth. Throughout hundreds of millions of years, existence has teetered on the razor's edge of total annihilation. Oceans have been drained, skies choked by volcanic plumes, and asteroids have struck with the finality of a death warrant. In the blink of a geological eye, more than 70% of all life has been erased. Again and again, yet, following every such catastrophe, the planet's biological rhythms have regenerated, pushing life toward unprecedented heights. Because there is no insurance policy against such a doomsday scenario recurring, we must study these past mass extinctions to grasp what they truly entail. Mass extinction events are defined by researchers as instances where the vast majority of life from the deepest trenches to the highest peaks vanishes within an incredibly brief window of time. Scientists generally quantify this as the loss of roughly 75% of species over a period spanning less than a few million years. While that time frame may seem substantial, it represents a mere heartbeat on Earth's 45 billion year clock. To visualize this compression, if Earth's entire history were distilled into a single 24-hour cycle, complex life would not emerge until roughly 5:00 a.m. Dinosaurs would only make their grand entrance around 11:00 p.m., and humanity would materialize only in the final few seconds. During that fleeting interval, life has faced near total erasure repeatedly. These resets were not purely acts of destruction. They served as catalysts, clearing the slate and creating openings for new biological lineages to ascend to prominence. Having defined these phenomena, let us turn the clock back 444 million years, a time when life remained predominantly aquatic. This era marked the first major mass extinction documented in the fossil record, and its severity was staggering. An estimated 85% of all marine species perished. During the Ordovician, the seas were brimming with activity. Ancient coral reefs thrived, while the oceans were dominated by countless plankton species, trilobites, and brachiopods, two-shelled organisms that superficially resembled clams. Conversely, life on land remained starkly limited, consisting only of sparse mosses and lichens clinging to barren rock. Forests and land-dwelling animals were entirely absent. From an extraterrestrial perspective, Earth was effectively a world of water. Geological data points to a global ice age as the primary architect of this tragedy. As tectonic plates migrated and coalesced near the South Pole, massive ice sheets began to accumulate. The formation of these colossal glaciers on the supercontinent Gondwana triggered a precipitous drop in global sea levels, delivering a terminal blow to marine life. Most organisms of that age were dependent on shallow, sun-drenched coastal waters for food and shelter. As the tide retreated, these habitats vanished, a catastrophe akin to pulling the drain plug on a massive aquarium. Compounding, this was a lethal disruption in oceanic chemistry. As temperatures shifted, oxygen levels in the water plummeted, spawning vast dead zones incapable of sustaining life. It was a dual assault. Marine organisms were forced from their homes, only to suffocate in the depleted waters. The toll was catastrophic. Once thriving groups disappeared, and seafloor rulers were relegated to the fossil record. The symbols of abundance, coral reefs, were nearly obliterated, requiring over 100 million years to bounce back. Trilobites, though they managed to survive the event, saw their immense diversity shattered. They would never again achieve their former dominance. In retrospect, the Ordovician extinction acted as evolution's inaugural great filter, pruning away the majority of the planet's nascent life forms, despite its inherent cruelty. The Ordovician catastrophe paved the way for a new generation of organisms to claim the stage. With much of the environment left desolate, those fortunate enough to survive were granted the opportunity to diversify. From this vacuum, during the subsequent Silurian period, life began constructing more intricate ecosystems, setting the stage for the biological expansion that would soon follow. Once the Ordovician crisis passed, life entered a phase of gradual recovery. The oceans were transformed into a paradise for a myriad of creatures, while on land, flora began to take hold and proliferate, however. Approximately 375 million years ago, a fresh crisis emerged in silence, rather than a sudden, violent jolt. This was a protracted decline that spanned millions of years, the Late Devonian Extinction, an event which saw the disappearance of roughly 75% of the planet's species, frequently dubbed the Age of Fishes. The Devonian period provided a stage for colossal aquatic life. Armored fish known as placoderms, possessing jaws built like crushers and reaching lengths of several feet, prowled the waters. Simultaneously, mollusks and corals thrived, and the first sharks made their appearance. On land, a botanical explosion occurred. Early vascular trees rose to form the first true forests. By absorbing vast amounts of carbon dioxide and pumping oxygen into the air, these forests fundamentally altered the atmosphere. It was a pivotal turning point as Earth became cloaked in green, and the first amphibians and insects began to venture onto solid ground. Unlike the Ordovician event, the Devonian extinction resulted from a convergence of multiple, interconnected factors. An oxygen crisis led the list of culprits. As forests expanded across the landscape, decaying organic matter was washed into streams and rivers, eventually reaching the sea. The process of decomposition stripped the oceans of oxygen, creating gargantuan dead zones. In a tragic irony, green plants, symbols of life itself, unintentionally drove many marine organisms to an evolutionary dead end. Volcanism further exacerbated the struggle. Extensive lava eruptions released heavy metals and carbon dioxide into the biosphere, while ocean acidification and volatile swings between scorching and frigid climates made survival increasingly precarious. Additionally, while likely playing a secondary role compared to the deoxygenation of the seas, some hypotheses suggest that asteroid impacts also contributed to the upheaval, stretching over nearly 20 million years. The Devonian extinction unfolded in successive waves. Ancient coral reefs, which had prospered for hundreds of millions of years, suffered a total collapse and did not reappear for another 100 million years until new species emerged. The placoderms, once the undisputed sovereigns of the deep, were wiped out along with countless plankton, mollusks, and primitive fish. This was more than a mere numerical loss. It represented the total crumbling of the pillars that supported marine ecosystems, while terrestrial plants and animals largely managed to persevere. The constant climate shifts made life arduous for early amphibian species. This hardship, however, pushed evolution to favor animals capable of living exclusively on land. If the Ordovician event was a freezing, sudden shock that left the seas gasping for breath, the Devonian was a chronic, wasting illness that slowly drained the vitality from the oceans. This was merely the opening act. Soon, the Earth would confront its most harrowing ordeal. The planet narrowly escaped becoming a desolate, lifeless sphere during the Permian's twilight, an event historians of the deep past have dubbed the Great Dying. If previous extinctions felt like minor shocks or lingering sicknesses, this was the definitive death blow. Standing as the most terrifying catastrophe our world has ever endured, life itself was nearly erased. As an overwhelming 96% of marine organisms and 70% of terrestrial vertebrates vanished into the void. During the Permian, the globe was defined by the singular supercontinent, Pangaea, which was girdled by the vast Panthalassic Ocean. It was a vibrant, flourishing age. Primitive reptiles and therapsids, the remote forebears of mammals, patrolled the land, while the seas teemed with mollusks, corals, fish, and insects. Even the iconic trilobites, though past their prime, clung to existence, yet within a geological heartbeat. Almost this entire tapestry of life was shredded. Most researchers trace the carnage to gargantuan volcanic outbursts in Siberia. 2 million square kilometers of terrain were entombed beneath molten basalt lava flows that remain visible today. This volcanic fury unleashed trillions of tons of carbon dioxide and methane, triggering a planetary fever. As CO2 permeated the oceans, the acidity spiked, annihilating creatures that relied on calcium-based shells, such as corals and mollusks. Simultaneously, oceanic circulation stalled, spawning massive hypoxic dead zones. Toxic sulfur compounds and leaking methane choked the atmosphere, while the protective ozone layer was compromised. Earth had essentially become a giant malfunctioning pressure cooker, characterized by stifling air, poisoned seas, and violent climate fluctuations. The result was total annihilation. In the oceans, the trilobite survivors of every previous crisis were finally extinguished, and coral reefs were wiped from the map. On land, the dominant therapsids were decimated, and insect lineages suffered massive losses. The ecosystems shattered so thoroughly that the planet was reduced to a suffocating, barren wasteland for millions of years following the event. The fossil record reveals a world struggling to breathe. Recovery was agonizingly slow, and the biological landscape remained bleak and impoverished. If the Ordovician had sounded an alarm, and the Devonian had acted as a slow-wasting disease, the Permian was the lethal strike that nearly finished the story of life. Yet this was only the midway point of the saga. After millions of years of scarcity, life tentatively bloomed again. By the Triassic period, the planet was once more a hive of activity, featuring sprawling forests, massive amphibians lurking in swamps, and a new generation of reptiles. However, around 201 million years ago, a new wave of extinction crashed down. While it lacked the absolute devastation of the Permian, this end-Triassic event was sufficiently powerful to clear the board, effectively opening the gates for the golden age of the dinosaurs. The Triassic period stood as a distinctive chapter in geological time. The supercontinent Pangaea remained a unified landmass. Hemmed in by a monolithic ocean, life endured a brutal climate, where sweltering summers alternated with frigid winters, and vast deserts dominated the interior. Diversity among the giant reptiles was immense, ranging from the archosaurs, the common ancestors of birds, crocodiles, and dinosaurs, to the therapsids, those early precursors to modern mammals. Swampy regions were ruled by gargantuan amphibians, some measuring several yards in length. At this stage, dinosaurs existed merely as a modest group, dwelling in the shadows of formidable rivals and far from the levers of planetary power. According to geological analysis, the end-Triassic catastrophe was inextricably linked to the tectonic fragmentation of Pangaea. As the massive continent began to fissure, the Central Atlantic Magmatic Province unleashed an era of colossal volcanic upheaval. This triggered a massive spike in greenhouse gases. Specifically, carbon dioxide emissions from the magma drove volatile shifts in global temperature. Much like the Permian disaster, the oceans became toxic, rendering survival impossible for many marine organisms. Rapid climate fluctuations pushed already delicate ecosystems into a state of total collapse. Consequently, roughly 70 to 75% of species were wiped from the Earth. The giant amphibians were effectively erased, their reign over the marshes coming to an abrupt end. Furthermore, many reptilian rivals that had once contested the dinosaurs for supremacy, such as the armored ettosaurs and the crocodilian phytosaurs, were consigned to extinction. Significant portions of marine life, including various corals, fish, and mollusks, also vanished. This tragedy birthed a massive ecological void, and it was into this power vacuum that the dinosaurs surged, ultimately claiming their status as the dominant terrestrial sovereigns for the next 150 million years. Having weathered these prior extinctions, the dinosaurs embarked on an era of undisputed, 150-million-year-long supremacy. They evolved into the ultimate icons of evolutionary success and biological diversity. From the long-necked giants like Brachiosaurus and the apex predator Tyrannosaurus Rex to the armored dinosaurs and soaring pterosaurs, they occupied every available niche. Beside them flourished a vibrant world filled with flowering plants, early avian species, and massive marine reptiles like the Mosasaurus. However, roughly 66 million years ago, fate intervened with a blow that remains the most jolting narrative in our planet's timeline: the Chicxulub asteroid impact. During the preceding Cretaceous period, Earth had enjoyed a warm, lush existence characterized by high sea levels, expansive grasslands, and thriving forests. Dinosaurs held dominion from the poles to the tropics, building an empire that felt invincible. Yet behind this veneer of stability, the heavens were preparing for the arrival of an uninvited guest, a 6-mile-wide celestial object, hurtling through the vacuum of space toward a collision with destiny. Approximately 66 million years ago, a colossal asteroid collided with what is now Mexico's Yucatan Peninsula. This impact unleashed a force equivalent to billions of nuclear warheads detonating at once. In a heartbeat, a massive crater now identified as the Chicxulub structure was carved out, spanning over 93 miles in diameter. So intense was the heat at the epicenter that rock and metal were instantly vaporized. As shock waves rippled outward, they triggered a global cascade of tsunamis, volcanic eruptions, and earthquakes. Picture a typical morning for the dinosaurs: the sun ascending, the lush jungle rustling, and then, in a terrifying flash, the sky ignited, plunging the world into a fiery inferno. This catastrophe was far more than a singular blast. It was the trigger for a lethal chain reaction. Vast quantities of debris were blasted into the upper atmosphere, where they settled into a thick shroud of dust that obscured the heavens for months or even years. With the sun effectively blotted out, vegetation perished en masse, and the fundamental food chain collapsed. Global temperatures plummeted, forcing a brutal and abrupt climatic shift that left large flora and cold-blooded creatures unable to cope. Simultaneously, sulfur and carbon dioxide were infused into the oceans from the impact site, rendering the waters toxic and decimating marine populations. Ultimately, 75% of all species were wiped from the Earth, a toll that included nearly every non-avian dinosaur. Countless others, from pterosaurs and coral reefs to gargantuan marine reptiles, were also erased. Forests that had once flourished under the shade of massive dinosaurs were reduced to skeletal ruins. In a mere moment on the geological clock, an empire that had reigned for hundreds of millions of years was brought to a permanent close. Yet life did not fully succumb. Certain groups possessed the specific traits necessary for survival: small mammals that lived in burrows and remained nocturnal, primitive birds that descended from feathered dinosaurs, and various insects, fish, and smaller reptiles. It was from these survivors, specifically the mammalian lineage, that humanity would eventually evolve tens of millions of years later. Looking back across the vast expanse of deep time, the Earth resembles a colossal stage where the play of life has frequently neared its final curtain. We saw the Ordovician ice consume the seas, the Devonian oceans strangled by hypoxia. The Permian turned the planet into a lethal inferno, the Triassic cleared by volcanic gases, and the Cretaceous empire dismantled by a single asteroid. Despite losses ranging from 70% to nearly 96% of all species, life miraculously clawed its way back from the shadows of extinction, time and again. The smallest and most fragile creatures have emerged as the victors, bridging the gap to new eras. Because of that resilience, we are here today to recount their tale. What remains deeply unsettling is the widespread scientific consensus that we are currently ushering in a new mass extinction. Unlike the disasters of the past, this one is driven not by volcanic fury or celestial impacts, but by humanity. The evidence is undeniable. Global temperatures are soaring at a pace unseen in recent history, fueling sea level rise, glacial melting, and increasingly extreme weather. Our planet's richest ecosystems, grasslands, coral reefs, and rainforests are vanishing at an alarming rate. Countless species, from whales and sharks to rhinos and elephants, are in steep decline due to human consumption. Our oceans are being choked by chemicals, oil spills, and plastic waste, which poison the very food chain we rely on. Current estimates suggest that the modern extinction rate is between 100 and 1,000 times higher than the natural baseline. If this current trajectory remains unchanged, the 21st century could well be viewed as the onset of the Sixth Extinction. The most harrowing distinction this time is the time frame rather than unfolding over millions of years. This collapse could be finalized within a few decades or centuries. However, unlike the trilobites or dinosaurs, we possess both the foresight and the agency to choose a different path. We are aware of the drivers behind this collapse. We understand the looming consequences, and we have the technological capacity to pivot. The question is no longer whether we are capable of facing extinction, but whether we have the courage to prevent it. Earth has endured for over 45 billion years and will certainly persist long after we are gone. However, our personal future hinges entirely upon the actions we take today. If we fail, humanity will be remembered only as another tragic, fleeting chapter in the planet's long chronicle of extinctions. If you found this topic thought-provoking, please consider sharing this video to spread awareness. Also, be sure to subscribe to keep up with our future deep dives into the mysteries of our world.